In this example, we're going to use a cap and bob viscometer to calculate the viscosity of the sample and select the appropriate model equation for the viscosity. Using the cap and bob viscometer, the cap rotates in different speeds and we measure the torque on the bob. And this table describes the data that we obtained. To make the calculations, we're going to use an Excel template where we have already prepared the calculation steps. Up here we can see the input data for the viscometer. This is the input rotational speed and the input torque. Both of them are measurements. Remember that we have to convert all the units to the SI system where we feel more confident to do our calculations. First step then, to convert to SI units. I will do all the calculations for the first measurement and then we will expand it to the remaining. So the rotational speed or radians is round per minute times 2 times the pi over 60 in this case, and then I have to convert the torque from the CHJS system to the SI system. In this case I have to multiply it by 0.0001 over 100. It might seem trivial, but following this kind of simple steps we make sure most of the time that we don't mess up with the zeros or the trailing zeros. Then to calculate the internal shear stress and the external shear stress, I can use the same formula with the different radius or diameter. So in this case I have to divide the torque with 2 times P times the radius over 2 at square 2 times the length. Now keep in mind that since I'm gonna expand this, drag this to the rest of the measurements, it's better to lock it down. So I lock down the number which corresponds to the rows. Now I'm getting this error because I forgot to convert the units from centimeters to meters. I do so and I drag it down. Another mistake, I forgot to change from diameter to radius. Okay, so now this is the first result. I can do the same for the shear stress. I like to drag a lot, so I drag the second one and now I'm changing the input. So the input is always the torque, length and the radius. This time the external diameter. The average of 2 I can estimate it with many ways. Let's use the average formula, average function. And here we are. Now I believe that everything is right, so I can drag it down to the rest. And so we have the average shear stress for each rotational speed. To calculate the shear rate, now we do have the assumption that the two diameters are very close, the cap and bob viscometer diameters are very close to each other. Remember this the ratio, the beta ratio. So now the formula of this is the rotational speed over the ratio, 1 minus the ratio of the diameters, the internal diameter over the external diameter. Again, since I'm gonna drag this down, I need to lock it. So it is. You can see that some of the graphs were already pre-designed, they take forms, but I will discuss them later on. And now the viscosity is the ratio of the shear stress to the shear rate. Now, in this first graph, we have the shear stress versus shear rate. And I have already added two trend lines, one with the linear formula and another one with the power formula. Can you guess? The linear one is for the Bingham model equation, and the power one is for the power law. Now I'm gonna use the regression results from the Excel graph to repeat here the calculation using as input, now in this case, the shear rate. So the shear stress following the Bingham model is the shear rate times 0.027 plus 14. So I click enter and I do the same for the power law, equals the shear rate. Now there's a different formula, power of 0.2337 times 8.3219. The viscosity in either case is always the same formula, the ratio of the shear stress over the shear rate. Same here. And now I drag all the calculations done. I see automatically that the other graph is also created. So let's zoom in and see. This graph is viscosity versus shear rate. I can see with the rectangle, blue rectangles, the input data. The input data that came from the Bob Viscometer measurements. I see with the red line the Bingham model, and with the green dashed line the power model. In both cases I can see that the agreement is very good level. Same goes of watching the data, the results. So that's it. See you next example.